Hello everyone, Shine is here. I'm going to demonstrate how you can use the online calculator for constructing your Gothic truss structure and for easy calculation. Of course, these calculations are used for verifying the solution. So first thing first, let me take you through the instruction document. So here we have a Gothic structure, and first thing first, the geometry of the truss is described here, and this truss can be constructed inside the online calculator using the joint numbers, and for each joint you have to enter the coordinates. So let's get this one started. So first thing first, I go to the two-dimensional calculator. So this is the link. So from here you can load the calculator. So I did that. So what you do is first you start to put the coordinate of each joint here. So I'm reading that from the table I've got here. So joint number 1 has 0, 0, so it's easy to create it. I put 0, 0, and when I say, so here let me reset that one. So this is reset. Oops. So here the design space is empty. When I enter 0, 0 here, add joint, now in your design space you have one joint created here. So then I do the second one, that is the coordinate x and y are x 100 and y 100. So this is my second node. So second node, that is 100, 100, add joint. Okay, so here I have two joint here, and imagine that I want to connect them with a frame object. So first thing, I have to enter a section area. This is not this is just for the displacement calculation, not related to your unit, but for the sake of doing it, let me just put some number here, 10, and the Young modulus I put 300,000. And now I want to connect joint 1 to 2 to make a link. So all I have to do is joint 1, joint 2, and add a frame object. And now you see that by doing that, I got a frame connecting 1 to 2. So if I keep entering everything here, and eventually I want point 1 to be a fixed one, and there are 8 nodes in my structure. So as you can see, there are 8 nodes. So that is node number 8. I want this one to be a roller contact. So when I define the 8 one, all I have to do is changing that one to number 8 and then clicking roller. That would be the roller support. For now, let's make 1 as a pin support. So I'm putting this 1 and clicking pin support. Now the pin support is being added here. Just you can get lost, just follow the procedure for all the coordinates according to this table provided to you here, and eventually what you get is this one. All right, so here let me clear the load. So number, yeah, for some reason this has been reset, and so you just select the joint number, and because the loads are being entered as the x and y component, what you need is from this document here, you go to the loading, and there are 16 different loading scenarios. So what you do is, for a given, this is for example loading at D or joint number 3, D, which is joint number 3, I am applying a force with an angle of theta 45 degrees with the x-axis. So the test load which I'm applying is 16 kilonewton. So 16 kilonewton is broken into 2 equal components. Apply that here. So I do this here, just choosing number 3 and put the components at the load, and then I compute the truss. When I do the compute, I will have a initial and deformed structure with all the loads written on it. The tensile loads are written in green and the compressive one in the red. So that gives you a quick way of evaluating and finding the forces, testing your hand calculation. So I hope this video helped you with that. If I want to show you a couple of solved exercises, so for example here for loading case number 1, I got these green ones as a tensile, and the maximum one is 12. So you see that 12 is the largest tensile force we have, which is applied to the frame number 1. This is frame number 1. So therefore, for your loading scenario, you will be replacing that link with a magnetic one. And then the rest is you have to find out what load is applied to that node to collapse the structure. And then for that, you have to measure the load taking capacity of this member. So this you do it experimentally. And according to the instruction, you can just base on one single solution with a test load of 16 Newton, you can extrapolate or find out that the collapse point by going through this procedure. I hope this demonstration helped you to conduct this test. Any feedback, please give me your feedback, and take care. Bye.